Last month, I published a video testing my CLI tool for PC-to-PC messaging. I mentioned that the messages sent through this program were not encrypted, which means anyone who intercepts packets can read the message with no extra effort. So in the following few videos, I would like to encrypt the messages, such that no one can make sense out of the intercepted packets without the correct password. But before diving straight into the code, let's review the overall design of the program I've built so far, and see what do I need to add to securely encrypt the messages. The program has three main cases. The first one is the listener mode, which is actively waiting for incoming messages. The second one is the sender mode, which sends the message to the IP address every time the program is called with a specific IP address and a message string. The third one is the error mode, which shows the correct way to use this program. Here you can see that the program is based on a fire and forget design pattern, which means no handshake overhead is needed between the sender and the listener. In other words, this is like sending letters through the post office without tracking. Thus, each turn of sending and receiving is a one-directional operation and no other information can be exchanged between two parties, which implies that only symmetric encryption is possible under this design. Talking about symmetric encryption, it is impossible not to mention Caesar cipher, which basically substitutes each letter by rotating the alphabet sequence. The number of dislocation of the sequence is the key. In this case, the key is 3. Similarly, although Caesar cipher is too easy for modern computers to crack, the idea of having a key for encryption and decryption algorithm for sending and receiving the messages is the same. However, instead of just manually picking a key or a password, which might be easy for humans to remember, there exist some hashing algorithms out there for generating a more secure key. Personally, I picked Argon 2 as the hashing algorithm and ChaCha20 Poly 1305 as the encryption algorithm. But before implementing these two into the code, I would like to first consider where do I get this password in the first place. So let's focus on how to let the program knows the password for encryption and decryption. In my case, I would like to simply ask the user for the password before the program sends or receives the messages. Thus, I would like to first create a character pointer for getting the password from the user before any other operations in both the sender and the listener mode. Then add the prototype of the getPassword function and create the actual getPassword function at the bottom. Inside the function, I would like to first allocate buffer for password with one more character for the null terminator, and add the corresponding header file for memory allocation and define the maximum password length. If the program failed the memory allocation, then it will print failed to allocate buffer for password and return null. Before moving on to getting input from the user, it's important that no one can see the password the user typed on the screen. Therefore, I need to first disable echoing in the terminal setting before asking the user to type their password. In order to do this, I created two variables for storing the old and new terminal settings, and add term.ios.h header file. Next, I obtain the current terminal setting with tcGetAttribute function in the term.ios.h header file. If the operation fails, it will print fail to get current terminal setting, free the allocated memory for the password, then return null. Once I get the current terminal setting, I can save it to the new one, and only change the echoing attribute of the setting in the new terminal setting variable. Afterwards, apply the new setting immediately. Again, if the operation fails, print fail to apply new terminal setting, free the allocated memory for the password, then return null. Since I already disabled the echoing function in the terminal, now I can prompt the user for entering the password, and make sure the program will appear before the program waits for the user input. Then get the user input. If it fails, restore the terminal setting, print fail to get user input, free the allocated memory for the password, and return null. After successfully getting the user input, restore the terminal setting. Finally, usually there is a new line character comes with the user input. I would like to replace the new line character with a no terminator, such that the password only contains necessary characters. If no new line character is detected, it means that the user input is longer than the expected length, which I flush the remaining character in the input buffer. Last but not least, return the password character pointer. One thing you need to pay attention is that, since I allocated a chunk of memory for the password and haven't freed within this function, this means that after I use the password, I need to free the memory later in the program. So far, I have finished adding the function for getting the password from the user for either encryption or decryption before sending or receiving the messages. In the next two videos, I'll encrypt the message before sending it out and decrypt the message after receiving it. If you want to follow along, consider subscribe to my channel. If you would like to download the code, feel free to visit my GitHub page. If you want to support me, you can give me tips on Ko-fi or buy my merch on Etsy. All of the links are in the description below. That's it for this time. See you in the next one.